In this video, I'd like to discuss higher order derivatives. Now, just from a purely big picture perspective, if you think of the derivative, what it's going to do is it takes a function f and it gives you a new function f prime. So f prime is a function, which means we could just go ahead and restart that process with f prime and say if we differentiate f prime, we get another function. Maybe we'll call it f double prime, the second derivative. The second derivative is a function, so we can start there and differentiate the second derivative to get f triple prime, which would be the third derivative, and so on. We can go through this process to calculate as many derivatives of a function as we would like. Standard notation that we can use for the derivative is typically we'll use either what we would call the Lagrange notation, which is with primes, or Leibniz notation, which is in terms of dy dx. So for this prime notation, we use f prime for the first derivative, f double prime for the second, f triple prime for the third, and you can notice that if we were to keep going with this and just writing primes, that notation would very quickly become rather cumbersome. So at the fourth derivative, we start putting, instead of primes, in parentheses, the number of derivatives we have. So that f sub n of x is just a fancy way for saying the nth derivative of f, where n here is any number larger than or equal to 4. For this alternative Leibniz notation, dy dx is the first derivative of the function y, d squared y dx squared is the second, d cubed y dx cubed is the third, and so on. So let's go ahead and find the third derivative for the function given below. So if we can differentiate it once, we might as well be able to play that same game over multiple times to find more than one derivative. So the first derivative, I'll say y prime, by the power rule, is 5x to the fourth plus 4x cubed. The second derivative, playing that same game again, we have 5 multiplied by the derivative of x to the fourth. The 4 comes down, and the new power is 1 less, plus 4 times the derivative of x cubed. The 3 comes down, and the new power is 1 less. So this is 20 x cubed plus 12 x squared. And now we play the same game one more time to get f double prime. And just an observation to note in terms of notation, when we say d cubed y dx cubed, this is the third derivative of y. So equivalently, we can use the prime notation, f triple prime. So for f triple prime, we differentiate the second derivative. So we have 20 times the derivative of x cubed. The 3 comes down, the new power of x is 1 less. Plus 12 times the derivative of x squared. The 2 comes down, and the new power is 1 less. So this simplifies as 60x squared plus 24x. And this will be the third derivative of the function y. So let's play this game one more time with the function sine of 5x. So the big observation to make is if I want to differentiate sine of 5x, well, that's a composition. You have the inside function 5x and the outside function sine. So the chain rule tells us that we differentiate the outside function, so the derivative of cosine is sine. We evaluate this at the inside function, 5x, and then we multiply this by the derivative of that inside function. So we're multiplying this by the derivative of 5x, which is the number 5. So y prime is 5 cosine of 5x. To find y double prime, that would be the derivative of the first derivative. So you have 5 multiplied by the derivative of cosine 5x. To differentiate cosine 5x, we once again use the chain rule. You take the derivative of the outside function. The derivative of cosine is minus sine. You evaluate that at the inside function 5x, and then we multiply by the derivative of the inside function, which is once again the 5. So this simplifies to be minus 25 sine of 5x. And one more application of the chain rule is going to get us y triple prime. So we have the constant minus 25, and we multiply this by the derivative of sine of 5x. To differentiate sine of 5x, we once again use a chain rule. We take the derivative of the outside function, cosine, we evaluate it at the inside, and we multiply it by the derivative of the inside function. So minus 125 cosine of 5x. And problems like this are great practice becoming comfortable with this pattern of using the chain rule.